Imagine explaining the entire universe in less time than it takes to scroll through TikToks. Too ambitious? Ambition is the fuel of geniuses. Or madness. Possibly both. In the next 10 minutes, you'll understand why apples fall, time bends, atoms ghost each other, and the universe somehow doesn't self-destruct, all while being fundamentally ridiculous. Blast through everything. Newton, thermodynamics, electromagnetism, Einstein, and the pure cosmic madness of quantum physics. Why time slows near black holes, to why your body is mostly empty space held together by particle drama. And no, your brain will not be refunded. Before we melt our brains, what even is physics? Physics is basically the universe's instruction manual. If the manual was written in riddles, full of math, and casually broke your sense of reality, it's the study of how stuff moves, collides, explodes, floats, sinks, sticks, stretches, spins, shrinks, and occasionally just vibrates for no reason. It's everything from why moons circle the Earth to how GPS works, because satellites account for relativity. Yes, Einstein is why your Uber's on time. Physics is motion, forces, energy, space, time, light, gravity, atoms, black holes, lasers, all the juicy bits that make the cosmos tick. And unlike other sciences, physics doesn't ask what things are. It asks how they behave, and why they're so dang weird. Think of it like this. If science was a movie, physics is the script. The laws, the plot twists, the explosions. Let's turn the page. Okay, rewind the universe a few centuries. No quantum craziness yet. Just apples, cannons, and one genius named Isaac Newton. Classical physics is basically the rules of reality. Let's start with Newton's 3 laws. Law 1. Objects stay lazy. If nothing messes with something, it just keeps doing what it's doing, forever. A ball in space, floating till the heat death of the universe. Your laundry? Still on the floor. Law 2. Force equals mass times acceleration. Push harder, it moves faster. Heavier stuff needs more push. It's why you can launch a tennis ball across a court, but not a refrigerator. Law 3. Every action has an equal and opposite reaction. Punch a wall, the wall punches back. That's physics and karma. Now gravity, Newton's biggest hit. He figured out it wasn't just apples falling. It was everything attracting everything. Yes, you're technically pulling the moon toward you right now. The moon is still ignoring you. Then there's inertia. This era of physics explained planets orbiting, cannonballs flying, pendulums swinging, and why skateboards work. It made the universe predictable, beautiful, boring almost. But here's the twist. Classical physics works perfectly, until it doesn't. Once things get really fast, super small, or extremely massive, Newton starts sweating. That's when Einstein kicks down the door. But before that, let's heat things up, literally. Welcome to Thermodynamics, where we study heat, energy, and why the universe is constantly falling apart. First, energy. It's the currency of the universe. You can't create it. You can't destroy it. You can only convert it. Thermodynamics is basically the rules for how energy plays the game, and the game is rigged. First law, energy can't just appear or vanish. It has to come from somewhere. Second law, everything gets messier, always. Entropy, aka the chaos meter, only goes up. Your room? Entropy. Broken eggs? Entropy. The universe? Slowly decaying into a boring, cold soup of entropy. Third law. You can never reach absolute zero. You can get close, but never quite hit full cosmic chill. The atoms just won't stop jiggling. Heat flows from hot to cold. Always. Why? Because the universe is lazy. It wants balance, and it's doing the bare minimum to get there. Thermodynamics explains why engines work, why stars shine, why your laptop gets hot. In short, energy is life and entropy is slowly eating it alive. But speaking of energy, let's shock some electrons next. Electricity and magnetism, two forces, one weird connection. Together they run the entire modern world and your nervous system and this video. First off, electricity is just angry electrons moving through stuff. Wires, nerves, lightning bolts, all just charged particles. They don't move alone. They create magnetic fields as they move, which means electricity and magnetism are literally two sides of the same coin. That coin? Electromagnetism. Shiny, fundamental, slightly terrifying. You move a magnet past a wire, boom. Electricity. Move electricity through a wire, boom. Magnetic field. It's like witchcraft, but explained by Maxwell's equations instead of potions. This is how motors spin, how generators generate, how transformers transform. Your headphones, microwave, and train systems? All electromagic. And here's the kicker. Your brain is an electrical jelly blob running on ionic impulses and low-voltage chaos. You are, quite literally, electromagnetic spaghetti with opinions. Now, ready to bend time? Let's invite Einstein to the party. Newton's laws were great, until things started getting fast, like near light speed fast. That's when a guy named Einstein looked at physics. Relativity is all about how space and time aren't fixed. They're stretchy, bendy, interconnected, like cosmic taffy. Start with special relativity. Two big ideas. Time slows down the faster you move, and mass increases too. So if you hop on a spaceship going 90% the speed of light, your clock ticks slower. From Earth's point of view, you age slower. That's time dilation. Yes, real, proven. That's why GPS satellites have to correct for time differences just to tell you where Starbucks is. Then there's general relativity. Gravity isn't just a force, it's space-time getting curved by mass. Think of space-time like a trampoline. Put a bowling ball, a star, on it. Boom, dent. Planets roll around that dent. That's gravity, but make it geometry. And the more mass something has, the more it warps space and slows down time. Stand next to a black hole? 1 minute for you, years outside. It's not science fiction, it's Einstein. Relativity explains black holes, time travel, kind of, why light bends around galaxies and why you can't just go faster than light unless you want physics to throw a tantrum. Oh, and E equals mc squared? That's energy and mass being the same thing, wearing different outfits. Einstein didn't break Newton's rules, he expanded them. But now, let's go microscopic, where the rules don't just bend, they break completely. Quantum time. Welcome to the quantum mechanics, where particles exist and don't exist at the same time, and logic quietly screams in the corner. Quantum mechanics is the physics of the tiny, atoms, electrons, quarks, the stuff your stuff is made of. And down here, reality stops behaving. First off, wave-particle duality. Particles like electrons, they're not just little dots. They're also waves. They're both, until you look at them. Then, they're one, or the other, maybe. This leads to the infamous double-slit experiment. Fire particles through two slits, and they create an interference pattern, like waves. But observe them? Suddenly they behave like normal particles. So, watching something changes what it is. Quantum's like, get reality when I say so. Then there's superposition. Particles existing in multiple states at once, until you measure them. Schrödinger's cat? Dead and alive until you peak. Very quantum. Very unsettling. And don't forget entanglement. Two particles so deeply linked that messing with one instantly affects the other, even across galaxies. Einstein called it spooky action at a distance. And randomness? Quantum doesn't play by deterministic rules. It rolls dice behind the scenes and somehow the universe still works. So, for the final boss, modern physics. So you've made it through falling apples, warping time, and electrons having identity crises. What's left? Modern physics, the patchwork masterpiece that tries to explain everything. At the center of it is the Standard Model, not a fashion line, but a giant physics chart explaining all known particles and the forces they use to poke each other. There are quarks, which make protons and neutrons, leptons, like electrons and neutrinos, bosons, which carry forces. The superstar, the Higgs boson, the particle that gives mass. Scientists spent $10 billion building the Large Hadron Collider just to catch this shy subatomic particles. But even with all that, the Standard Model is incomplete. We still don't know what dark matter is. The invisible stuff that seems to glue galaxies together. We don't know what dark energy is. The force making the universe expand faster. It's like physics handed us the cheat codes, but then half the level vanished. And then there's string theory, loop quantum gravity, multiverse theories, brilliant, complex, and currently unprovable ideas that might rewrite everything. Watch this if you want to understand why wood is rare than diamond.